Chemistry, we're on to our next lesson, and this is on the subject of electronegativity. So there's two concepts that are related, but we're going to focus on one of them. Electronegativity is how much an atom wants to pull on an electron toward it from an atom to which it is covalently bonded. Now, we have not covered that concept yet, covalent bonding. We will in a few lessons, but basically it's pulling electrons toward it from a bonded atom. Electron affinity is generally how much an atom wants to pull an electron toward it from the outside, that's outside of itself. So you will not understand the difference between these two definitions at this point, but that's okay. We're really going to focus on a general definition of electronegativity. And that is, we will use the term electronegativity for both of these definitions throughout the class. The reason is simply that's the way books treat it. Really, rarely do books talk about electron affinity. They simply talk about electronegativity as meaning an atom pulling in outside electrons that were not originally belonging to it. So electronegativity is how much an atom wants to pull an electron toward it from either an outside atom or from an atom to which it is covalently bonded. So that's the definition that we're going to use for electronegativity. Anytime it wants to pull in an electron from outside of itself that does not originally belong to it. So the man represents electronegativity. It's basically the pull of the protons. And electronegativity wants to pull in an electron. So there goes the electron getting pulled in. Electronegativity is measured on a scale of 0 to 4 called the Pauling scale. Fluorine has the highest electronegativity at 4.0. So let's look at the trends in electronegativity. Electronegativity increases as you go up a group and to the right in a period. So you'll notice that these trends are the same as they are for ionization energy. In other words, the elements with the highest electronegativity are in the upper right-hand corner of the periodic table. Those are the non-metals. They have the highest electronegativities. Electronegativity is greatest in the upper right-hand corner of the periodic table where fluorine is. So you see there is another perspective diagram, and it's very similar to the one for ionization energy. So what it really comes down to a lot is how strong do the protons hold on to electrons. For ionization energy, which is also binding energy, it's how much does it hold on to its own electrons. And for electronegativity, it's how much do the protons of an atom go outside of itself and pull in outside electrons. So it has to do with the ability of protons to pull electrons towards it. The elements on the right side of the periodic table are called noble gases. Okay. Noble gases have no electronegativity. We will learn the reason for this later. Well, we can really learn the reason for it right now. We learned in class that noble gases have full octets. Their outside orbital is already full. And since it has a full valence orbital, all the electrons, all 8 electrons, are filled in its valence orbital, it doesn't want to take in any more electrons. So even though noble gases have very high ionization energies, they don't give up their electrons, they also don't want to take in any new electrons. And so therefore they have high ionization energy, but they have no electronegativity, no desire to pull in an outside electron. So noble gases are not shown because they have no electronegativity. So here's the explanation, and it's very similar to that for ionization energy. Electronegativities are highest when the nucleus has more protons, that's as you go across a row, and the atom has fewer orbitals, that's as you go up a column. So if we look at the row, the second row again, as we did with ionization energy, lithium has a lower electronegativity than fluorine because it has the same number of orbitals but fewer protons. So lithium doesn't pull in electrons as well as fluorine. And going down, Bromine has a lower electronegativity than fluorine because bromine has more orbitals and more core electrons. The electrons outside of the atom are screened more from the nucleus, so the atom can't pull in electrons as well. You notice it's pretty much an identical explanation for electronegativity as it is for ionization energy. So here's the thing to remember, it's almost identical to ionization energy. In fact, it is. Increasing electronegativity when you go from left to right because more protons with the same number of orbitals, and from bottom to top because you have fewer orbitals and the electrons are closer to the nucleus. Actually, it's easier for the protons to reach outside of the atom to grab outside electrons and pull them in when you have fewer orbitals. Let's do a quick comparison of what electron affinity is and discussion of that. So I'm going to put them both up here. So electronegativity is a measure of how much an atom attracts electrons when covalently bonded to another atom. So electronegativity is measured on a scale from 0 to 4. There's no units of measure for that scale. It's just a scale that a famous chemist named Linus Pauling made up. And basically fluorine, if you see it there, has the highest electronegativity on the periodic table. You don't have to memorize these numbers, but you should have a feel for them. Fluorine is the highest electronegativity on the periodic table at 4. Oxygen is next at 3.5. And it's the electronegativity, the high electronegativity of oxygen that plays a part in many of the biological processes in your body that create energy. It's the high electronegativity of oxygen. We'll talk about that sometime in the future. But you notice there's not a lot of elements with electronegativities above 3.0. There's only 4 of them. And then there's not that many with electronegativities above 2.0. Most elements on the periodic table are metals that you don't see on this chart that have electronegativities below 2.0, below 1.0. Now, electron affinity is a measure of the amount of energy an atom gives up when it accepts an outside electron. Remember that ionization energy is how much energy you have to put into an atom to take an electron out. This is the opposite. It's how much, when you take an electron in, it gives off energy, because a system wants to go to a lower energy. So it will take in electron if that allows the atom to go to a lower energy. And so you see the table of energies there for electron affinity. So electron affinity measures the amount of energy an atom gives up when it accepts an outside electron. A more negative energy value means the atom is more readily accepts the electron. So negative energy means the energy goes out when the electron comes in. So electronegativity is how much an atom wants to pull on an electron toward it from an atom to which it is covalently bonded. We'll discuss covalent bonds later. And electron affinity is how much an atom wants to pull an electron toward it from outside of the atom, from outside. Okay, and we will use the term electronegativity for both of these definitions, as do most textbooks going forward in class. All right, and that takes care of this lesson on electronegativity, and we will move on next to the lesson on atomic radius.